So hi everyone, welcome to the next video of solving most important DSA interview questions. So in this video, we are going to solve another linked list problem. So the problem is intersection of two linked lists. The description of this question is very messy. So let's make you understand this description in a very easy manner. So here you will be given with this type of linked list. So you don't have to worry about how this has been made. So you will be given with this. And you have to find whether these two linked lists are intersecting or not. Here you can see that these two linked lists, the first linked list is this, right? The second linked list is this, right? So both are different linked lists, but they are intersecting at C1, right? So you have to find whether they are intersecting or not. If they are intersecting, so you have to return that point where they are intersecting. Otherwise, you have to return null, right? So to make you understand this, there is a condition given in the description that there is a note that you can see here that a note that the linked list must retain their original structure after the function return. So this is not what I'm talking about. Okay. So here is the condition that they have given that the test cases are generated such that there are no cycles anywhere in the entire linked list. So they are saying that there will be no cycle in the entire linked list, right? So let's take this another example here. Okay, let's copy this. Okay. So let's take this example linked list here, right? So you can see here that they have mentioned in the description example that you must be thinking that this one node and this one node is common node. So you will make it as an intersection. So this is not an intersection point. I know these nodes have similar value, but they are indicating the totally different memory locations, right? So this is a different memory location and this is a different memory location. We have to find a node which have a same memory location, right? So, and that node is 8, right? Where the intersection is happening. So the answer of this example question is 8 here, right? So how you will solve this question? So again, in this question, similar to previous question, we will use 2 pointers, right? So how we will use that? So I'm going to show you some observation here. Some questions are solved by just observing them out, right? Okay. So I have considered these 2 pointers here. So let's try to do some movement here, right? So I moved this pointer here forward and the other pointer here, right? Then again I moved this pointer here and this pointer here. And I moved again this pointer here, right? So you can see that at some point these two pointers are pointing to same memory location or same node. So this means that there is a intersection in these two linked lists, right? Let's say if we had moved our slow pointer, this upper pointer first. So let's move it out first. Let's say we moved it out here. We moved this here. We moved this here. And again we moved this here. Then it came here and it came here, right? Now it came here and it came here. Right? So now you must be noticing that when we moved our pointer randomly without noticing anything, so you can see here we missed out this point, right? Intersection point. So how we will encounter this condition? So what we will do, you will again move this pointer forward and this pointer forward, right? As soon as any single pointer out of these both points to null, what you will do, you will make this pointer the pointer of these other linked list, right? You made this pointer of that. So basically what I try to say that when this pointer was pointing to null, you made this pointer to point out the head of the another linked list, right? So you pointed out to here and again you move this pointer forward. So it's pointing to null again. And then what you will do, you will move again this pointer forward. So now this pointer is pointing to null. So again what you will do, you will make it a pointer of the another linked list and start with the head, right? Now again you will move it out here. Again you moved it out here. Then again you moved it out here. Then again you moved it out here. So you noticed that we again came to the single point of intersection, right? So this was the logic of this problem, that if you don't encounter intersection point in a single way, so what you will do, you will interchange the pointer of the two linked lists, right? So in the second time, you will definitely get the pointer, right? Intersection point. And if there is no intersection point, so basically you will not get this pointer together, right? So this is the way of solving this question. So let's jump onto the code. So here we have given the heads of the two linked lists, right? So first of all, what we will do, we will check for the condition that if head A is already pointing to null, right? Or head B is already pointing to null. So what we will do, we will return null. Why? Because uh, if both the linked list don't have any node, so they don't have any common intersection point, or otherwise if one linked list is there but another linked list head is basically pointing to null, means its length is 0. So in that case also there will be no intersection point. So this condition is basically referring to that only, right? So what you will return null pointer, because we don't found any intersection point. Now what you will do, you will create two pointers here, basically of type list node. Let's call it as A. Let's call it as A, which will basically point initially to head A. You will create another pointer B, which will initially point to head B, right? Now what you will do, you will run your while loop until your A is not equal to B, right? So inside this while loop, you will check for the condition that uh, if your A pointer is pointing to null, so basically we can use a conditional here. So basically, if your A pointer will be what? If your A pointer is pointing to null pointer, right? So what you will do, if this is true, then what you will do, you will make it as B pointer. Okay, you will make it as, you will make it to point to head B, that is another linked list head, right? Otherwise, what you will do, you will move this pointer forward, right? The same condition you will use for B also. If B is pointing to null pointer, then what you will do, you will move it to the head of another linked list, or what you will do, you will, else what you will do, you will move it forward, right? At the end, what you have to return, you return anything. You return A, let's say A. Why? Because if there is an intersection point, so at the end they will point out to the same pointer, right? They will point out to same node. So you will return anything, either you return A or B, it doesn't matter. Otherwise, if they don't point to the single node, you will return a null pointer, right? So it's returning uh, either common node, or what it's returning, null, right? So let's try to run this code. So you can see here our public test cases are passing. Now let's try to submit this out. Yeah. So our code has been accepted. So this was the solution of this code. Uh, I think it's a little bit tricky, because you had to absorb this logic that the pointers are again meeting in the second round, right? So that's about in this video. So let's meet in the next video. Till then, have a nice day.